So I gave you the assignment. I wanted you guys to give me the distance, displacement, and position as this person travels from here to here to here. If you went through and watched the trigonometric thing, I did not mention at the very end to do this. If you haven't done it yet, then please pause the video, take a few seconds to try to give me, or minutes, whatever it takes, to try to give me that answer. Okay? So I'm going to take a little breather. Oh, and during that breather, if you haven't paused, please pause. Okay, now on to that answer. What's the distance that that person travels? Well, he travels 10, 10, and 10. So 10, 10, and 10. So that means the distance that he travels is going to be 30 meters. Okay? So again, if you don't remember what the definition of distance is, how far an object travels, try to put it up in that corner. If it ends up getting blurry, I might end up replacing that. Or I'll probably have these in class. Displacement. How far away is he from the origin? Well, what we're going to do is we're going to do a little bit of vector addition. We're going to do that vector addition in component form. Alright, so what we're going to do is we're going to talk about steps. Step 1. How far and in what direction does this person travel this way? 10 meters. In the x direction. Okay? Does he travel anything in the y? Well, hopefully you can see that in step 1, this section right here, he doesn't travel any in the y. So what I want to do is I want to keep a placeholder, something to keep track of that. So what I'm going to do is I'm going to add 0 meters in the y. I can add 0 to anything I want. It doesn't make a difference. It doesn't change anything. I'm just keeping track of the fact that I'm going to go 0 meters in the y. Okay? Step 2. He moved up. Okay? So, how far did he go in the x direction as he's doing step 2, as he's moving in this direction? Well, hopefully you can see by now that he doesn't move any in that direction. Okay? So, keeping that placeholder, I'm going to have 0 meters x direction. Now, how about the y direction? How much did he move in that direction? Well, he moved 10 meters y. And then, if you think I'm going over this a little bit too fast, remember that I've talked about this in the other videos. If you need a little refresher where I'm getting the zeros and where I'm getting the 10, please go back and look. And if that still doesn't help, please approach me in class. I mean, that's kind of why I'm doing this, the way I'm doing it, so I can focus on things that you guys don't understand individually instead of trying to address the whole class and then have 20% of the people not listen to me. Step 3. This is the new part. So we've already gone from here, that's step 1, to here, that's step 2, now to step 3. How far does he go in the x direction? Well, he goes 10 meters, right? In the x direction. Yes? Kind of. How about negative 10? My axis, negative x direction. It's going this way, negative 10. Okay? Hopefully everybody sees that. If you don't see that, then please ask me. I'll try to explain it in more detail. How much does he go in the y direction in step 3? He doesn't go down in step 3 at all. He just goes straight across. So the answer to that is going to be 0 meters y direction. Now, to give me the displacement, we're just going to add all of that together. Total. Okay? So I'm not worried about the x's. Adding zeros gives me nothing. So these zeros I'm not going to concern about. I'm just going to kind of scribble them out right now. I put them in there because I wanted the placeholders. So it's like, oh, look, I can say all my x's here. I can say all my y's here. If I didn't, then I have to go, ooh, that was an x, that was a y, that was an x. But now I can just look at it vertically and determine what that is. So total. Once again, I can only add x's to x's and y's to y's. So, excuse me again. I'm going to say, here's my x's. I'm going to start with the parenthesis. 10 meters in the x, that was from step 1. Then a negative 10 meters in the x, that was from step 3. There's my x directions. The other one was a 0. I can put it down there, but I know it's not going to contribute anything, so I'm going to leave it off. And then talking about my y direction, I'm going to say plus my y's. Well, I have 2 zeros in there, so it's not terribly important. So I'm just going to not worry about the zeros. I'm just going to worry about the number there. I've got a 10 meter in the y direction. Okay? That's my answer. Sort of. Well, I know 10 meters in the x and the negative 10 meters in the x is the same as if I were to go this way and then come back. If I went this way and came back, what would be my displacement at that point? 0. I'm 0 away from my starting position. I've returned back to my starting position. So 10 meters minus 10 meters in the x direction gives me 0 meters in the x direction plus 10 meters in the y. That's my answer. Okay? 0 meters in the x, 10 meters in the y. So my displacement at that point is 0 meters x plus 10 meters in the y. Cool? Now think about it. His displacement is how far he is and in what direction from where he started. That's the definition of it. How far? Well, he's only 10 meters away from his starting position. If I were to go this way instead of going around this way, it's only 10 meters. And in what direction? Well, positive y direction. So there's my answer right there, 10 meters in the y direction. I've got my displacement. And now position is following suit because I have my origin here. So that means that I've got 0 meters in the x direction plus 10 meters in the y. Now, homework. I know this videos are supposed to be homework, but what I want you guys to do is I want you to come to class when you've got this, when you've gone through these videos, and I want you to give me the answer if you were to travel from here to here to here to here. Okay? Those 4 directions. I want distance, displacement, and position. Okay? The idea of this assignment, this homework, is so that I know where you're at. So because I'm giving you guys the opportunity to work on your own and then ask for help during class time. So boom, 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 boom should tell me, oh look, this person is now finishing up the vocabulary for position, displacement, and displacement. Position, displacement, and distance. I hope I said them all. So it gives me a check of where you are. And I'm going to be asking of this off and on over the course of the semester. It's like, all right, now for homework, I want you to bring in this. Okay? So, your homework, I'm not doing this as a video, your homework is to tell me what his distance, displacement, and position is if he was to go all the way around this circle. Okay? Cool? Alright, that's it for that. What I'm going to do really quick, the next thing, is I'm going to talk about displacement as a mathematical definition and how it's related to position. And I'm also going to finally come up with the answer for this, how can I get position different than displacement? Okay? Cool? So, next video is going to be mathematical definition of displacement, and then after that will be the answer to the question that you've all been looking for.